All right, so now we've got we're basically doing the same example again, but this time we're in standard form instead of in vertex form. So we want to find the vertex, the axis of symmetry, all that good stuff. All right, so our vertex, we're going to say, hey, I know we're at negative b over 2a, right? H is equal to negative b over 2a. So our b is so negative 2 over 2 times 1. So negative 1. What's my k going to be? I'm going to plug in negative 1. Negative 1 squared plus 2 times negative 1 plus 6. So that's 1 minus 2. So it's negative 1 plus 6 equals 5. All right, so there's my vertex. And I know that the axis of symmetry is going to go through the x-coordinate of that vertex. So the axis of symmetry is going to be x equals negative 1. I do know that this is not my a is equal to 1, so it's opening up so that the vertex is a minimum. And we've got it sketched kind of here. Okay, sorry about that. So we've got it kind of sketched out here. We've got all the questions answered. Is this skinny or wide? It is, let's see, my a is 1. So it is neither. It is the same as the basic x squared. What is the domain? It's a polynomial. It's always all real numbers. Right, so I forgot to write our vertex, right? Negative 1, comma 5. There we go. And what's the range of the function? Of course, our lowest point is at 5. So, and then we're going up to infinity. So 5 with a bracket because it's included up to infinity. Where's it increasing? Where's it decreasing? It's very repetitive here, right? Where's it increasing? It's increasing to the right of the vertex. So increasing 5 to infinity, and remember 5 is not included there. Decreasing negative infinity to 5, because remember, oh, I just made a mistake, y'all, because I got distracted, right? Because we were just talking about range. So, because this should be the x-coordinate, don't make that mistake on the test, right? This should be negative 1 to negative 1. So negative 1 to infinity for increasing, in negative infinity to negative 1 for decreasing. Sorry about that. All right. So another example, same story. Like I said, it gets really repetitive. Where's the vertex? Axis of symmetry, max, min. So what do we know here? We know that this has been reflected over the x-axis, so it's opening down, and it has been stretched because our a is bigger than 1, so vertically stretched. I can't spell. So where's our vertex, our h location? Remember, negative b over 2a. So our b is 6. Our a is minus 3. All right, so we're at negative 6 over negative 6, which is 1. And then our k location, we're going to just plug in 1. So we get negative 3 times 1 squared plus 6 times 1 minus 8. So negative 3 plus 6 is negative 3 and minus 8. Right? Negative 3 plus 6 is 3. Minus 8 is minus 5. There we go. We'll get it eventually. So there's 1 minus 5. So we're about here. And we're opening upwards, except that it's going to be pretty narrow. So we'll just kind of make it look a little narrow. We do know, oh, you know what? I really need to stop, right? Because it's not opening up. It is opening down. We already said that. Y'all, my college student got home in the middle of this video, so I'm like discombobulated, right? Where is our y-intercept? It is at 0, negative 8. So there's a second point here. So this is not very good graph paper for it, right? So we are looking at vertex 1, -5, our axis of symmetry, x equals 1, right? There's our axis of symmetry. It is the vertex is a maximum value, and we've sketched our function. Is it skinny or wide? It is skinny because it is narrow, vertically stretched. What is the domain? All real numbers, imagine that. What is the range? -infinity to -5, right? That was where our vertex was. Where is it increasing or decreasing? Well, so this time we are increasing on the left side, because remember we read these right to left, so increasing from -infinity to 1 and decreasing 1 to infinity, because remember these are x intervals that we're giving here. Okay, so we've got the last part of this, but I'm going to break for one last, hopefully last video.